8-6 part 1, we're going to solve rational equations in this part, and then in part 2 we're going to solve the rational inequalities. So a rational equation has the variable included in a fraction, and a lot of times the variable is in your denominator. So here's an example: 15 plus x over x equals 6. This is a rational equation. We have to solve for x, and it's a pretty tricky equation, but what we can do to solve these is eliminate the fraction. So you eliminate the fractions by multiplying everything in the equation by the lowest common denominator. And in this case, our denominator is x. So if I wanted to solve this rational equation, I would multiply both sides of the equation by x. Multiplying by x actually cancels out the fraction and makes it a lot easier to solve. Okay, so let me show you an example of actually solving them. We've got three fractions in this equation: 9 over 28 plus 3 over z plus 2 equals 3/4. And our job is to figure out what z is. What's the value of z that makes this equation true? Well, we need to figure out what the lowest common denominator is. The lowest common denominator in this case would be, let's look at the numbers, between 28 and 4. 28 is the lowest common multiple. 28 goes into 28, and 4 also goes into 28. Then I also need the factor z plus 2. So that's my common denominator. Let's multiply every term by this denominator to see what happens. Okay, so the first fraction we're going to multiply by 28 times z plus 2. Just the top of the fractions today. We're going to multiply this one by 28 times z plus 2. And we're going to multiply the last fraction by 28 times z plus 2. As long as you're multiplying everything in the equation by the same thing, we're not really changing the value of our equation, or we're not really messing with the variable. Okay, so why does this work? Well, if we multiply by the lowest common denominator, I can cancel out common factors on top and bottom. For example, in this first fraction, I can cancel out the 28s. What I'm left with is 9 times z plus 2. No more fraction because I canceled out the bottom number. Plus, in this middle fraction, I can cancel out the z plus 2's. That's a common factor, and I'm left with 3 times 28 equals, over here I can cancel out the 4 and the 28. 4 goes into 28 7 times. So now I have 3 times 7, or 21, times z plus 2. So now I've rewritten my equation with no more fractions. That's the trick. That's what you need to do. Okay, so let's solve this thing. In the first part here, I've got 9z plus 9 times 2 is 18. Use the distributive property. Plus 3 times 28 will give me, what do we get here? I don't have a calculator on me. So 3 times 20 is 60. 3 times 8 is 24, so we get 84. And then over here we're going to distribute, and we have a 21z plus 42. Okay, now let's combine like terms. The 18 and the 84 need to go together, so I've got 9z plus 102 equals 21z plus 42. And now let's solve for z. I'm going to subtract 9z on each side. 21 minus 9 gives me 12. So 102 equals 12z plus 42. Let's subtract 42 on each side. And I get, I'll write it up here, 60 equals 12z. Divide each side by 12. And we get z equals 5. Okay, now if you wanted to check your answer, you could certainly plug it back in and make sure that everything works here. So I'm just going to check this first example. All right, so we want to make sure that 9 over 28 plus 3 over 5 plus 2, or 7, 3/7 equals 3/4. And you can check to see that that does in fact work. So you can always check your answer by plugging it back into the equation. Let's try another example. So this time I have x plus 6 equals negative 5 over x. I only have one fraction here, the negative 5 over x. So multiplying by the denominator is super easy this time. I need to multiply everything by x in order to cancel out my fraction. Everything in the equation needs to get multiplied by x. Now let's rewrite what we've got. X times x is x squared plus 6x equals, over here I canceled out the x's and I just have negative 5. Now let's set this equal to 0. What I really have here is a quadratic equation. X squared plus 6x plus 5 equals 0. At this point, what you can do is try to factor it. If you think you can factor it and solve for x. So that's what I'm going to do, because I noticed that if I use the two numbers 5 and 1, 5 times 1 gives me 5, and 5 plus 1 gives me 6. Now that I've got the two factors, we set each factor equal to 0, and we can solve for x. So we're going to write x plus 5 could be 0. That makes x equal negative 5. Or the second factor, x plus 1, could be 0. So x equals negative 1. With these quadratic equations, you typically come up with two solutions. If you can't factor it, then you need to use the quadratic formula. I'll just put it over here quick so you've got it. X equals plus or minus b. I'm sorry. Start that over. I almost forgot what it was. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you want to write this down in your notes, because I have a feeling that you're going to end up with some quadratic equations here that won't factor, and so you're going to need to use the quadratic formula instead to solve. Okay? All right, so the two answers are negative 5 and negative 1. Again, you could check them by plugging in these numbers for each x and make sure that the equation is true. Okay, let me show you a couple more examples. So this time we have r plus 1, r minus 1, and r squared minus 1 as our denominators. Okay, so what I would do, I notice that I've got a difference of two squares, so what I would do here is factor r squared minus 1. R squared minus 1 actually gives us two factors, r minus 1 times r plus 1. So now what's my lowest common denominator? Well, it would have to be these two factors, r minus 1 times r plus 1. If I multiply every fraction by my lowest common denominator, you're going to see the denominators cancel out. Okay, so that's what I'm going to do here. So the first fraction, I'm going to multiply by r minus 1, r plus 1. Second fraction, multiplied by the same thing. And the third fraction, multiply by the same thing as well. Okay, so we're multiplying on the top of our fractions in the numerators, and our goal is to cancel out each denominator. Look at how the denominators will cancel out. We're going to get rid of every single fraction here. And this last fraction, both factors cancel out. So now we want to rewrite what we have. Well, in the first fraction, I canceled out the r plus 1, so I'm left with 2 times r minus 1. Then we're subtracting 1 times r plus 1. And I'm going to put that 1 there to show that we're really distributing a negative 1 here. And then on the right side equals, all of these factors canceled out, so I just have negative 2. So now it's a pretty easy equation to solve. Let's go ahead and distribute. 2r minus 2. Here we're distributing a negative 1 minus r minus 1 equals negative 2. Before you move on to any kind of solving here or undoing operations, let's combine like terms. So the 2r minus 1r gives me r. The negative 2 minus 1 gives me minus 3. And I've got r minus 3 equals negative 2. Well, let's add 3 to each side, and I get r equals 1. Now, if you take a look at our solution here, r equals 1, there's kind of a problem. Go back to the original equation here. Could I plug in r equals 1? Let me just show you quick. If I want to check my solution, I'm going to plug in r equals 1. So I have 2 over 1 plus 1, or 2, minus 1 over 1 minus 1. That gives me a denominator of 0. That's where the problem occurs. equals -2 over 1 squared minus 1. That also gives me a denominator of 0. So this solution actually doesn't work. If I plug in 1 into the original equation, I've got fractions here that are undefined. So r equals 1 is not a solution. It doesn't work in the original equation. And you have to ask yourself, is there anything that we missed? Is there anything else that does work? In this case, no. So we're going to have to say there's no solution. Okay, so enough of me talking. I want you to try one on your own here. Think about what your common denominator is. Maybe I'll give you a little hint so you can start. I want you to multiply everything in this equation by 6 times x minus 6. And you're going to see how doing that will cancel out each fraction.